This lesson is for section 9.1. We'll be using Excel functions. I think I listed 5 different Excel functions are listed, but in fact, I think we're only gonna use 3 of them in this section 9.4, and I made sure that you only need these 3 functions that we're going over together in this notes to complete your 9.4 homework. Well, maybe 9.5 we may use as rate and NPER, but we're mostly using the PMT, the payment function, PV, that stands for present value, and FV, future value function, to answer some of these questions regarding how much money should be deposited today, or how much money am I going to have in 30 years. Some of these very important questions, I think, like if somebody wants to retire at 68 and wants to have a certain amount of retirement money, how much money should be deposited? Those things. So I think these are very applicable. I love this section, and I love the fact that we'll be able to use Excel as our calculator to answer some of these otherwise very big formula and very big in like multi-step problem. If you don't use Excel calculator, I mean, there is a way for us to do it, of course. There is a formula, and in fact, you've used them before. The payment function, the payment calculator, the formula, or the APY, APR, those formulas work. But this section, we're going to use the functions in Excel. So if you do not have Excel, you will need to download it and make sure to have it, okay? We'll go ahead and read these definitions with you real quick, just talking about what are the 5 functions that Excel has that we can use. Excel has 5 built-in financial functions. The arguments for each function are the other 4 financial functions in order. What they are saying is if you want to use these functions, you need to give Excel 4 inputs, because they're going to ask you, like, for example, say that you're interested in what is going to be my payment amount. Excel will need to know, hey, what's the interest rate? How many compounding period are we talking about? What's the present value and what's the future value? So in order for Excel to give you an answer, they will ask you 4 different inputs. And 4 inputs, we're gonna talk about how to how to type these inputs when we are going over these examples together. You don't really have to memorize it, as we'll have an open note exam and open note everything really. So just make sure, what I want you to be able to do today after this lesson is know that these functions exist, and I want you to be able to read a word problem and be able to pick out which one of these, well, I say 5, but really we're only going to be using 3 functions. Which one of these 3 functions are appropriate for us to use in order for us to find the answer? So please know that these functions, payment, present value, and future value functions exist, and we're going to practice how to use them in this lesson together, okay? So I'm going to skip the rate and NPER. Rate basically finds you the periodic rate, and the NPER is talking about how many periods is required, but the payment is going to be the big one. And in fact, payment function is the one that you're going to use on your project too. And on a separate video, when I go over step number 3 of project 2, new cars, we will use this payment function to calculate the monthly payment for the car that we're going to buy, okay? So let's take a look at the PMT function. The payment function is asking you to type in the rate, NPER, PV, and FV as the inputs, okay? As 4 inputs that it's gonna need. What it does is it's gonna calculate the payment required to achieve some financial goal. So something like this. Say that you wanna save $1 million in the next 40 years. But it's not going to be as easy, as simple as million divided by 30 divided by 12 for a monthly payment, because we get something called interest rate, right? So what you want to what you want to make sure to type is like what's the interest rate, or how many compounding period, how much do you have in your bank account right now? That's the present value, and what's the goal, the future value. So payment function is used if you want to figure out what's going to be that monthly or yearly payment. Okay, the present value, um, it's gonna ask you for almost the same input, rate, end per payment, and future value. But what it does is it's gonna calculate the present value required to achieve some financial goal. So in cases like this, say that I want to deposit a big lump sum of money in my bank account and just let it grow over the next 20 years. I'm not gonna make any monthly payments, but say that I just wanna deposit like $3,000, and I'm sorry, not $3,000. So say that I just want to have about $5,000 in the next 5 years. How much money should go into my bank account right now for me to have $5,000? The present value the function is used if you want to find out how much money should I put in today, the present day. Okay. Now, what about the last one, the future value? This one calculates the future value required to achieve some financial goal. In other words, something like this. What if I put in $3,000 today and an APR of 5%, compounding monthly, blah, blah, blah. How much money am I going to have in, let's say, 12 years? What is the money that I'm going to have in the future? So we got to read these word problems very carefully. If it's asking for how much money do I need today, then you're going to go with present value. If it's asking for how much money am I going to have in the future, then we're going to use the future value function. And the payment, if it's asking for how much is going to be my monthly payment, then we're going to go with the payment function. So I kind of categorize these examples. Like the first ones that we're going to look at is the present value. The second one is going to be future value. And the last one, we're going to just end with the payment. When you are doing your Math Lab homework, they're not going to tell you which function to use. But you're going to be able to read it, and you're going to be able to tell, oh, they're asking for how much the payment is. Oh, they're asking for what the future value. You'll be able to tell. Okay? They're not making it extra tricky for us to figure out which function we need. But what we're going to do is we're going to start with the first function, the present value function. In other words, how much money do I need today to achieve some kind of financial goal? Okay? Now, you know how I usually write on my iPad to take notes, but today I'm recording this on my MacBook because I'm gonna have to use Excel, and I don't know if I can download Excel on my iPad. So if you know how to do that, you let me know. But I'm just gonna go ahead and record this lesson on my computer, and I will just type and maybe screenshot the answers, and then I will also scan this and put it on Canvas. Okay. All right, the first two are pretty straightforward. Let's go ahead and look at number 1 and 2 together. How much must be deposited today? I'm highlighting that. Why? Because that highlighted part is telling me that I must use the present value function. How much money should be deposited today? That's present day, right? Into an account with annual compounding. I think I'm enjoying these highlighting functions. Annual compounding with an APR of 5%, in order to have $85,000 in how many years? 10 years for a down payment on a house. Assume no additional deposits are made. Now, what does that last sentence, what does that mean? No additional deposits are made. Now, this isn't very common because for me, when I'm saving, I put little bit of money every month in my bank account. But this is a case where a person just decide to put a big amount of money once today and then just wait for this money to grow in the next 10 years. And the goal for this person is to have $85,000 in 10 years. So the 4 things that are highlighted in pink is going to help us figure out what those 4 inputs are going to be. And maybe I should highlight this part too. This is also telling us something. No additional deposits are made. That means we're not going to make any monthly payments. We're just going to put a big amount of money in one time and then just wait for it to grow. All right, I'm going to use the present value function. What I'm going to do is I'm going to go in and just type this here. And then I will take a screenshot and I'll show you how I'm typing those in Excel too. So this is a function that I'm going to use, and you know why I'm using the present value function, right? I'm using the present value function because of the yellow highlighted part. The yellow highlighted part is telling me how much must be deposited today, right? That's asking for the present value. Now, what's the rate? Now, rate is going to be, remember they gave you 5%, right? It's 5%, and usually you will have to divide this by n value. Like how many times are we compounding per year? But notice, because this was annual compounding, n is simply 1. So if it's annual compounding, you don't have to divide this annual percentage rate by anything, because 5% divided by 1 is just going to be 5. So that's okay. For annual compounding, no need to divide by anything. Just 5% is fine. Now, N per. N per is how often your deposit or money will be compounded to earn the interest. Now, with annual compounding for the next 10 years, we're looking at 10 times our 10 compounding period. So this one is, I'm putting 10 because each year you get one compounding with annual compounding, but we're doing that for the next 10 years. So N par is going to be 10. Now, what about this part? PMT, payment amount. Are we making any payments? No, right? They said assume no additional deposits are made. So for PMT, type in 0. No payments are made. Now, what about the future value? How much money do we want to have in the future? We want to have 85,000. Now, this is it. If you type this in Excel, they will tell you what the present value should be. So you ready? I'm going to go ahead and, you know what? I typed this in. Maybe I can just copy this and put this on my Excel. So I'm opening an Excel, a blank one. Just going to use it as a calculator. And I'll just make it a little bit big over here. And I will type in =, PV, present value function. Now, when you type this in, it gives you the 4 inputs, right? Can you see? I know it's a little small, but the first thing they're asking is the rate. The rate is 5%, comma, N per is 10, comma, PMT, the payment amount is 0, and the future value is 85,000. And be careful when you're entering these numbers. If you miss a 0 or 2, that's gonna be bad. That's gonna give you a wrong answer. So 85,000, and we don't have to worry about type. So close the parenthesis and hit enter. Now, before I hit enter, let me go ahead and take a screenshot of that. And then I will hit enter. Now, here is the answer. We got it. And I'll also take a screenshot of that so that I can include it. And I'll put it over here on my Word doc. How much money must be deposited today? Well, in order for us to have $85,000. Now, hold on a second. Oh, did you see what I did? I entered way too many zeros. My goal wasn't 85,000. My goal, I accidentally typed in one extra zero, you see that? So I wanted to have $850,000. That wasn't it. See, it doesn't make sense for us to deposit more money and then lose money in the next 10 years. So that's what I said, right? I said, we gotta be careful entering these zeros, but I made a mistake. All right, let me go ahead and take out that 1 0. But you should be able to tell that your answer doesn't make sense. If you're making an investment, you should put small amount of money and want it to get bigger, right? So if you get an answer that's bigger in the beginning, that doesn't sound right. So let me change that to $85,000. Now that's going to be good. But as I want to complete this notes for people who just kind of always follow the notes instead of watching the video, I want to have a screenshot ready for them. All right, and I hit enter. And the answer should be, how much should be deposited today? $52,182.63. That's how we do these problems. All right, so bear with me as I insert these over here. Picture from file, and I'll get faster at this. I think it was these two. I'll just put it over here so that you guys can have it. So this is what I entered on Excel, and this is the answer I got. This much money should be deposited today. And I wonder if I can just do like in front text and bring this over here. Oh, that looks amazing. I think I'm enjoying this. All right, so we're gonna do one more. We're gonna do one more. But that one's gonna be a little bit different. Okay, so you ready? Okay, I'm gonna go over here. The second one. Saving it. Sorry if I'm going a little slow today. How much must be deposited today? Now, I'm highlighting that part in yellow. Why? Because that's telling me that I must use the present value function into an account with, oh, now this part we have to be careful. Monthly compounding and an annual APR of 8%. It's not, I'm sorry, APR of 8%. This is not annual compounding. This is monthly compounding. So every month, our money is going to get compounded for bigger and bigger interest. In order to have, now here's the goal, we want to have $65,000 in how many years? 6 years for down payment on a house. Assume no additional deposits are made. See, that's the part that I don't understand. When people save money, they put money in every month. But well, that's okay. Maybe somebody just wants to put in a lump sum of money in and just wait 6 years for it to grow it to $65,000. So because of the yellow highlighted part, I know I'll be using the present value function. So let me copy this and let's talk about what we are going to type in here, okay? So what are we typing? Let's see. We want to first give them the rate. What's the rate? Rate is 8%, but watch very carefully, okay? This is where we can mess up. If you type in 8%, it's not going to give us the right number. What you must do is you must divide this by 12. Why? Because it was monthly compounding, and for monthly, remember even in that big compounding monthly formula, we divide it by n, right? So remember, when you have monthly compounding, you divide by 12. When you have daily compounding, you divide by 365. For quarterly, you will divide by 4. So these are the key, and you have to be very careful. For monthly compounding, I'm going to divide by 12. So 8% divided by 12 is the rate. What about n per? Now listen, if you type in 6, it's going to be incorrect. It's 6 years, but we're getting what? Monthly compounding. So how many months do we have in 6 years? What you can do is 6 times what? 12. And remember that was the exponent in our the compounding formula, right? So make sure you do 6 times n, 6 times 12 in this case. But if it was daily compounding for the next 6 years, then you would have done 6 times 365. All right, payment. What's the amount of payment? No additional deposits are made, so put 0 in. What about for future value? How much money do we want to have in the future? We want to have $65,000. Now we entered everything. We're ready to bring up our Excel and let's type in our formula. I'm going to delete the one that I had before. So equal sign, present value, 8% divided by 12, comma, 6 times 12, comma, 0, comma, 65,000. I have to be careful because I tend to put too many zeros in very often. So that's it. If you enter that, and if you hit enter, they're going to tell you how much must be deposited today. Hit enter. The amount that we need today is about $40,285.04. Okay, so that's how you will get the answers. I'll go ahead and bring these screenshots over here. I think I'm gonna go ahead and in front of text. I'll just put this answer over here, and I think Excel is doing these as like a negative number. That's when they do negative number, they put it in a parenthesis, but don't type in negative answer, okay? You just go ahead and type in the number part, okay? I think we can make one of these entries like inputs, what's it called? negative and then they will spit out a positive answer, but I don't think I'm going to worry about that really. The right number is going to be correct. Alrighty, so we're doing good. That's how you would do the present value functions. Couple more. How about I just make them go down a little bit? All right. Just because I'm so slow with this, guys, I'm sorry, it may take longer, but maybe after a present value, we'll take a quick break and then we'll come back and do the future value functions, okay? Now, a couple more, let's try these ones. Just because I think it's kind of challenging to remember to divide by the number of compounding period per year and multiply by that, I want to do a couple more with you, okay? All right, you want to have $60,000 college fund in 13 years. How much will you have to deposit now? Oh, how much will you have to deposit now? Why am I highlighting that in yellow? Because that's telling me that I need to do present value function. That's the keyword that I need to use, the present value function. Under the scenario below, assume that you make no deposits. No deposits into the account after the initial deposit. What I highlighted in pink, that's telling us the payment is going to be $0. We're not paying additional payments every month. We're just going to put one big amount and we're just going to wait. All right, let's take a look at the first one. APR of 6.5% compounded daily. All right, you ready? Let me go ahead and type in the formula. Equal sign PV. What first? We need to give them the rate first, right? And you don't have to memorize these order. We can just go up and look at it. You know what? In fact, let me go ahead and copy this, the inputs, and then I'll just fill it in this way. All right, let me go ahead and do that here. The rate is going to be what? Rate is 6.5% divided by what number? 365. Why? Because for daily, number of compounding period per year is 365. Because we have 365 days. Now, N per, how many days do we have in what? Oh, I'm sorry, I forgot to highlight a couple important things. They said they want to have that $60,000 in 13 years. $60,000 in 13 years. So for N per, I'm going to do 13 years times 365, right? Basically, what I'm finding, this part is finding how many days do I have in 13 year, right? Now payment, what's that going to be? That's going to be 0. Now what's the future value? What's the goal we want? We want to have $60,000, right? Now, if you enter that into Excel, we're going to be able to figure out what that initial amount, initial deposit now must be, okay? All right, let me bring up my calculator. Alrighty, so typing in, let's delete everything. Equal sign, present value, 6.5% divided by 365, comma, 13 times 365, comma, 0 for no payment, and then 60,000 for my future value. That's the goal. So if I go ahead and you know, I've been taking screen. I guess I don't have to take a screenshot because I got that typed up there for you. But if I hit enter, the amount that I need to deposit today is $25,775.38. And I actually went and did your homework, guys. I went and did your homework last night, and because I was worried about rounding issue. Excel never gave me the wrong rounded answer. So you can trust this function. You can go ahead and use it. It's going to give you the right answer, okay? Oopsies, I see my text is flipping. So, we got the answer. Let's do 2 more, okay? Now, next one, APR of 6.8% compounded quarterly. Oh, okay. So I'm gonna go ahead and say equal sign PV. 6.8%, but this is compounded quarterly. So what should you divide this by? Divide by 4, because we have 4 quarters in a year, comma. All right. The next one is N per, number of quarters in 13 years. How many quarters do we have in 13 years? We have 13 times 4 quarters, right? Comma. Payment is 0 as we're not making any additional deposits, but we still have the same goal of $60,000. All right, that is what we're going to enter into Excel together. And notice how, well, I can't tell because it's compounding less frequently, but it's got a slightly higher APR. So I can't really tell if it's going to be higher than 25 or lower than 25, that amount above. But let me go ahead and type this in. Right, I'm just going to go ahead and copy what I typed, and I hit enter. The answer is $24,972.48. Okay? All right, let me go ahead and put the answer here. I hope you're getting this. Is this okay? All right. Ta-da. Oopsies, I flipped that. Alrighty, now the very last one. How about APR of 7% compounded annually? Annually. Now that's the easy one, right? Present value, we're still looking for the present value, 7%. Now, what should you divide the 7% by? If I'm following this rule, I'm dividing by something, right? Number of annual compounding in 1 year. Well, it's annual compounding. So here, you really don't have to divide by 1. You can just keep it as 7%. And next one, I was going to do how many years do we have in 13 years? Well, that's just 13. Really, 13 times 1 is 13, right? Now, the payment is the third input. Payment is 0. And the goal is to have 60,000. Okay, now although this one had the least frequent compounding period, they did offer the highest rate. So wonder if what's gonna be the highest. So because if I'm making a financial decision, like I want to go with the option A, B, or C that will offer me, that will tell me the lowest amount of money is necessary, required today, because I don't want to put more money in today if they're gonna all grow to be the same amount, right? All right, let me go ahead and type this in and get the answer. Where did you go, Excel? I'm typing in equal-sign PV 7%, comma 13, comma 0, comma 60,000. Was it really 60,000? Yes, it was 60,000. 60,000. Okay, hit enter. The amount of money that I will need is $24,897.87. Now this is great because if you just have a little piggy bank, and you keep money in your piggy bank, no piggy bank will give you any interest. But if you put those money in those accounts or bank or some kind of financial institution, they will give you interest for letting them borrow your money, and that's how you can make money using your money, right? Alrighty. So if you're making a choice, like which option are you going to go with? Now, are you going to go with the option that requires you to put the most amount of money in today? No, that's my money, right? I'm going to go with the third option because this is asking me to only put $24,897.87. But all these amounts, out of these three amounts, this one was the least amount of initial deposit that I need, but they're all gonna grow to be $60,000 in the next 13 years. All right, so I think I'm doing really good. I'm doing really good. How are you doing? All right, let's go ahead and look at the last one, number 3. And what I'm gonna do is I'm gonna take a quick break, okay? I'm gonna come back and do the future value. But I think this one just took the longest because it was the first time for us to explore these present value. But the other ones are very similar, really. They're very, very similar. So let's go do the very last present value example. And let's take a quick break, okay? All righty. Just gonna add some spaces here. All right, I'm gonna zoom in. Suppose John wants to accumulate $120,000 for retirement in 30 years. Because once John retires, he doesn't want to go back to work. So he wants to have all that money in his account when he retires in 30 years. So he has two choices. All right, so I guess he's making comparisons. Plan A is a single deposit into an account with annual compounding and an APR of 5%. The second one, Plan B, is a single deposit into an account with continuous compounding. Now, guys, I'm going to have to highlight this and have to tell you the bad news here, okay? We need to do this one by hand, okay? And, I mean, I've done my research, guys. I tried to look it up to see if there is a way for us to do compounding interest, continuous compounding, using the present value, and I just couldn't find it. There is no way for me to, because, I mean, for compounding quarterly, you divide by 4, right? For compounding continuously, you're going to divide by 12. But compounding compounding continuously, like it's getting compounded every second continuously. So what are you going to divide by? Infinity? You can't really do that. But we do know the formula that goes as, let me go ahead and type in that formula for you. Well, we will do this by hand, just this one. But then option plan A, we can do that using the present value function. But remember that good function, A equals P times e raised to the RT power. We're going to use that one for continuous compounding. So we'll do that one by hand. All right. All right, what's going on? But notice how both plan A and B are requiring a single deposit, right? They're both requiring a single deposit. Not multiple deposit over the 30 years. That will be no more normal, but maybe John just has a lot of money that he can put into an account and just let it wait 30 years. All right, I'm gonna do the first plan first, all right? Plan A. How much does John need to deposit in each account in order to reach the goal? We're looking for present value of this investment. So let me go ahead and start typing. The first one, John must deposit, let me go ahead and type in the present value function, equal sign, present value of, now what was the interest rate for the plan A? 5%, but this is getting divided by, now take a look, this is annual compounding. So what are you going to divide that by? Nothing, right? Just divide by 1 because there's 1 year in 1 year. 5%, comma, next one is the number of compounding period. Now that's 30 years. So the question is, how many years do you have in 30 years? That's just going to be 30. I don't have to multiply 30 by 1. Comma. Notice they said single deposit is required in the beginning, but no additional payments are required. So I'm going to go ahead and do 0 for the payment amount. And lastly, the future value. John wants to have $120,000. It makes it easier for us to type in a comma for like 120, but don't do that because Excel doesn't want to have a comma in the middle of because when you say comma, they're going to try to move on to the next entry, okay? Or next input. So that's what you're going to enter in Excel to figure out how much John needs to deposit. To have $120,000 with plan A. All right, let me go to my Excel and type that in. I just copied it. Oopsies, I don't know. That there. John will need to deposit $27,765.29. I got the answer. Let me go ahead and copy this over here. Alrighty. I'll do text wrap in front of text so that I can put this beautiful answer in this blank. Okay, so if he goes to plan A, that's how much money he should have and he should put in his bank account. Pretty nice, right? He put that much in and that $27,000 will grow into $120,000 just earning interest. So that's what you will do for plan A, which we can use the payment function. But the second one, like I said, there's no way for me to use the payment function for the continuous compounding case. So what I'm going to do is I'm going to do this by hand, okay? So let's get a pencil out. Let's try to write some work down, but we do know how to solve this. Now, let me go ahead and write that big formula down. The formula is, I'm trying to insert an equation here. A equals P times, is A equals P times e raised to the, oopsies, e raised to the RT power, R times T power. Now that is the continuous compounding formula. Like we talked about how in nature, things don't wait until end of the day or end of the month to, grow or decay. So continuous compounding or any continuous exponential growth or decay, we used that before. So I know you can use this, but we're going to have to plug in some values into this equation together. Now, A is the ending amount. A is the amount that we want to have in the end. So we want to put in $12,000 on the left side of this equal sign. Now notice, P is the initial deposit. P is the initial value of this investment, which we are trying to figure out. So we don't know what P is. We're actually trying to find P. So leave that blank. Now let's plug in everything else we know. What about rate? What's the rate they were offering in B, Plan B? Let me see. Plan B was offering an APR of 4.5%. Now 4.5% in decimal is 0.045, or I think, yeah, you can keep it as 4.5% if you want. And how many years? How many years? Forgot. 30 years. John's waiting 30 years. Now that's what you're going to write down. And this is what you're going to solve for, P. Now notice, if you want P by itself, P is currently getting multiplied by this term, right? What cancels out multiplication, guys? Division, right? So this is what we're going to do. We're going to divide both sides by, that E term. So what I'm doing is I'm dividing the left side by this E to the 0.045 times 30. And I'm also dividing that term, that number, 220,000 by that E term. If I do that, I wonder if I can draw lines here. Because I just couldn't figure out how to connect my iPod to show my writing. But there's got to be a way for me to put some sticks. Like I may be able to do. Okay, take a look. This will cancel out with that. Oh, whoopsie. I'm going to copy this. This will cancel out. Oh no. This will cancel out with that term, right? So we actually solved it. We solved for P just now. Oopsie, sorry. Probably you're much faster at writing this than me because you're doing this with your pen and pencil. So P is simply going to be 120,000 divided by E to the 0.045 times 30. Now, you will need your scientific calculator to type this. I'm going to go ahead and just round this to the nearest hundredth because we're talking about money, right? How much is that going to be? So let me go ahead and use my calculator for the day is, Excel. So I'm going to go ahead and type this in my Excel calculator to figure out the answer. So I'm doing 120,000 divided by 120,000 divided by E raised to the 0.045 times 30. That's what I'm entering. And let me take a screenshot of that. Oh, but you know what? I forgot to type in an equal sign in front of it. Anytime you want Excel to evaluate your calculation, you want to use it as a calculator, you better give them the equal sign before, okay? Okay, let me hit enter. Oh no, why are you saying name? Maybe my cell is not big enough. Maybe it's just not recognizing what E is. That's probably what it is. So Excel doesn't know what my E is. So Excel was not successful evaluating that for me, but that's okay. I got my scientific calculator right next to me on my couch. Or I can go to, because I want to show you how I'm typing this in. I'm just going to go to Desmos scientific calculator. I'm Googling a scientific calculator online so that I can evaluate that amount. 120,000 divided by E to the 0.045 times 30. Oh, this guy did a beautiful job evaluating. You see, I went to Desmos calculator and they found the answer for me. Let me go ahead and bring this over here. So it's very common when you're doing your math problem, you do everything so perfect, but then like if you're typing something in incorrectly on your calculator, they're not going to find the right answer for you, right? So if you're having these calculator moments, write me a quick email with a picture so that I can see what's going on, and then we can fix that together, okay? All right, hold on. Let me go ahead and bring that to the same page. Thank you for your patience as I'm being kind of picky about formatting of my notes right now. The answer came out to be $31,108.83. Now, this is the amount of money that John will need to deposit into this um, continuously compounding account to get the same $12,000 in the next 30 years. So now let's be John and let's think about which option is better for him. Ooh, which option is better for him? The one that's asking him to only put in 27,000 or the one that's asking him to put in 31,000? Oh, John should go with plan A, because plan A is asking you to put less amount of money in today, right? But they're going to end up with the same amount, $1,200,000 in the next 30 years. Why? Why do you think? I mean, I would think continuous compounding is just always better than annual compounding. But if you take a look at their, what's it called, their interest rate, notice the first one was offering 5% interest rate. What am I doing? Why is that highlighting? I wanted to highlight this interest rate. The first one is giving John a 5% interest rate. That's not highlighting. Ah, there's my highlighter. 5% interest rate, and the second one was just giving John 4.5%. So that tiny little 0.5% interest rate difference made all that difference, right? So I think that was about 42 minutes. So I hope this present value function went over very well. Uh, I hope you understand how this works, because after this, and I just gotta introduce you two more functions: future value, which is almost the same, and then the payment function. So I'll be back to record the others ones. But you should be able to do about like 1/3 of your homework now. Okay, alrighty.